Question 1. Read each question carefully. Determine the best answer to the question from the 4 answer choices provided. Then fill in the answer on your answer document. A dichotomous key of different mollusks is shown. Which mollusk moves by jet propulsion and does not have an external shell? Step 1. External shell is present. No external shell is present. So no external shell is present. Go to slide 3 or step 3. Moves by jet propulsion. It's a squid. Number 2. Which statement best describes how a virus replicates? So a virus is not considered an organism because it cannot reproduce on its own. So let's see which one of these statements works. A virus divides into 2 identical viral or virus particles before infecting the host cell. Well, no, it can't reproduce on its own. A virus enters a host cell and uses the material from the host cell to produce new virus particles, definitely involving a host there. Multiple virus particles fuse and form a large particle that breaks apart, releasing new virus particles. There's nothing mentioning a host there, so it's out. And the last one, multiple virus particles break down in component parts, which then reassemble into new copies of the virus. So again, the last one doesn't say anything about a host cell. So the only one with the host cell would be the second one, B. Oil spills in the ocean affect marine food webs. Animals that are initially affected by oil spills include sea otters, seabirds, and other organisms that spend most of their time on the ocean surface. Based on the food web, how would a significant decrease in the sea otter population due to an oil spill most likely affect this ecosystem? Okay, so if we see the sea otters are a food source for killer whales. So the killer whales would lose a food source. Sea otters consume mussels and sea urchins. So the mussels and sea urchins lose a predator. The sea urchin population would increase, causing the kelp population to decrease. So the sea urchin population would increase because the sea otters aren't there to eat them. And if they increase, then the kelp might decrease because they eat the kelp. So A is a good possibility. The fish population would increase in response to the changes in the mussel population. I don't think that they're even connected. They're not even in the same food chain. The mussel population would increase in response to the changes in the algae population. So the mussel population would change, but in response to the sea otter, not the algae. And the killer whale population would increase, causing the fish population to decrease. Well, the killer whale is going to be losing one of its food sources, so it's kind of like the opposite. So the best choice is A. Number 4, which of these shows an example of an insertion mutation? So we have RSTUV-XYZ, and then we have STUV-XY. So we lost R and Z, so that's a deletion. Then we have RSTUV-XYZ, and then we have RSTV-XYZ. That's also a deletion. RSTUV-XYZ, RUTSV-XYZ. That's an inversion. They're flipped. And then RSTUV-XYZ, and then all of a sudden there's a K and L. So that one is the insertion. So the answer would be D. Number 5. In a central Texas grassland, the producers incorporate 12,000 kilojoules of energy from the sun into their tissues. About how much energy would be incorporated into the tissues of herbivores? So, first, let's think about the food chain or pyramid or whatever it is that we're looking at: producers, primary consumers, secondary, tertiary, quaternary. So, your producers, your plants, are going to be eaten by your herbivores. So if we have 12,000 kilojoules in our producers, then for the herbivores, remember your 10% rule. So it's 10% of 12,000, which makes it 1,200 kilojoules.